So while we're waiting for the reaction, I wanted to show you our IR spectrometers, and we have two of them that are up and running. These are in room 331A, so right next to the organic lab. And so we have two of them set up, and they are a little bit different because they have different accessories. So this one is set up for transmission, and so it has the Smart Omni transmission, and inside here we have this will hold a salt plate, and this one over here has an ATR accessory. It's called the Smart ITX Diamond accessory. It is set up to measure solids. And so you put your solid right on here. It uses ATR, attenuated total reflectance, which does make the spectrum look a little bit different. We'll talk about that in as we look at it. But it is so incredibly convenient compared to other methods for getting an IR of solids. So these are both Thermoscientific Nicolette IS-10 infrared spectrometers. Before we run a spectrum, we want to check, so we've got collect, experiment setup. So we're going from 4,000 to 525, and it knows that we have the Smart ITX accessory, so that's important information. And if we look at collect, we are running 8 scans, 1 resolution, and the final format is % transmittance. Okay, so that looks good. And now we're going to collect a background. So it reminds us, please prepare to collect the background. So I know that there's nothing on here, so that's what I want. So I say, okay, collect the background. And it's going to take 8 scans. You can see that it's running there. After a few scans, it's going to put the spectrum on the screen, even though it's not done yet. So 8 scans takes not very long at all. Okay, so now it's done, and it says the data collection has stopped. Add to window 1, no, because I don't need to see this data. I just need a quick look. And this is a normal background spectrum when you're looking at an ATR. Okay, so I'm just gonna say no, and I'm gonna get ready to run my own sample. Here is our spectrum of our starting material. And you'll probably notice it doesn't look quite like the spectra that we see in our textbook. And part of it is a difference of using an ATR rather than doing a liquid sample or using a solid in a KBR pellet. And sometimes it's just a difference of being a real lab, real data as opposed to perfect data. So let's look at this more closely. We have right here is our 3,000, and so up from here we have our important signals. So this tells us if it's just under 3,000 we have sp3ch, just over 3,000 we have sp2ch. This is a little bit choppy, but still it's nice and broad. And it's in the region of above 3,200 to about a little over 3,400. So this would fit for an alcohol OH. Down here we have the fingerprint region, nothing too critical, except we do have this one really strong signal, and that is just above 1,100. That makes sense for a carbon-oxygen single bond. Okay. Now you'll notice this doesn't look the same as what we see in the book, and part of it is about the strength of our CH signals and also our OH in this case. They're not as strong as what we often see in the book, especially when we look in comparison to the signals down here. And that is probably the only drawback of using the ATR accessory, is that at the higher wave numbers, the signals become a little bit like compressed. So instead of being really long and strong like normal, they end up being a little bit shorter. Okay, so the information is still there, right? We have our signals, they're in the right range, they're just a little bit shorter than what we would expect to see. Okay, so once we have our spectrum, then we can go to find peaks. And we have this line that comes across, and this shows us our threshold. So if we just click up higher, then we are going to label more peaks, but it gets pretty messy. If we go lower, then we are labeling less, but we're missing some important peaks. So in this case, if we were to go all the way up here, then we have quite a mess over here. So please check with your instructor, but often what I recommend, let's get this right here to get these labeled, not too much extra stuff. And unfortunately, we don't have these labeled, but that's okay for now. This looks good, but we do not want to print from here. We want to click replace to get back to the main window. Okay, so now we're in the main window and we have our peaks labeled. If these are cut off, we would come up here and look at view full scale. Yeah. Okay, but we can see everything just fine. So now you can print it. And then what you could do, if your instructor says it's okay to do it this way, when you move the cursor here, down here, you can see where you are on the X and Y axis, right? So we can see that this signal here is at 2988, so that fits for SP3CHs. And then this one over here, we're going from 3303 over to 3443. So again, that fits for an alcohol OH. So we can write this on our spectrum and we should be good, right? So print this and make sure that you have the information that you need. And then what you're going to do is click on clear because that clears the data so that the software is ready for the next person. And you're going to clean off the ATR. So you unscrew this, you're going to wipe off as much as you can, typically using Kim wipes. We have the reminder to clean it with ethanol only. Don't use acetone because that can damage the parts. So we're going to use a Kim wipe. We're going to wipe off the plate as well as the underside of the tip here. We have to make sure that that is nice and clean. And finally, we are going to take our product with us. We are not going to leave our spatula and our material for somebody else to clean up because nobody else is going to clean it up. It's your responsibility. Now we're getting ready to run the IR on our liquid. So this time we are going to be running it on salt plates. So we have the sample holder. But before we run the spectrum, we have to run a blank. Actually, first let me show you, is this set up correctly? We're collecting 8 scans, resolution 1. We're looking at percent transmittance. And if we look at bench, we are collecting from 4,000 to 525. So that's what we need. So that is okay. So now we're going to come up here and say collect background, and it gives us the reminder, please prepare. So we've got the holder in there, but there's nothing else, so okay. And then this shows us when it's going to start taking the scans. It's not done, but it still puts the background up on the screen. So this one looks very different than the background using an ATR, but that's okay. This is a normal background for a regular transmission. So the data collection has stopped. Do we want to add it to the window? Nope, because this is just our background. So now we are ready to run our sample. Here we have the salt plates. This is what we are going to use for running a liquid. So these are made up of sodium chloride, which does not absorb in the infrared region. And so that works great. We can apply our sample, and then we put it into the beam of the infrared, and the sodium chloride doesn't absorb, so what we will see is what our compound absorbs. But because these are made of sodium chloride, they are quite fragile. So you can see there's lots of little chips. There are some others that are broken, but you also want to avoid getting these wet, because water will just dissolve the salt plate. So we just need to draw up a drop of our product, and we are going to expel just a single drop. I tried to get it in the middle, but that's okay. And then we put on the other plate, and you can see how the sample spreads. We want to make sure we're only handling it by the sides, and then we bring it over here. I need a third hand. And then we put our salt plates on the holder and close the lid. And then, because we are switching over to the computer, we take off our gloves, and now we collect sample. Again, we can give it a name. We don't have to. Okay. It reminds us, please prepare. Yes, it's prepared. Once again, we can watch as it starts to scan. Okay, so this is our product. Okay. It's still getting some more scans, but now it's done. So data collection has stopped. So yes, add it to window 1. Now, what do we see at a glance? This looks very different from our starting material. And not just because this is a liquid taken by transmission rather than a solid taken by ATR. If we look in this region over here, so around 3300 or above, we don't have any strong OH signal anymore. So our product obviously does not have OH. When we look at our CH stretches though, we were kind of expecting a dehydration, but we don't have any evidence of sp2CH because all of our signals are under 3000. We still have this signal here, which is actually junk. This is just some of the background that didn't get subtracted away. Here we have a very strong signal just above 1700. That's not what we expected. An alkene, a carbon-carbon double bond, would absorb around 1650, not 1700, so we don't have any evidence of an alkene either in the carbon-carbon region or in the carbon-hydrogen region. All right, so we didn't get what we expected. And then we have a few other signals, but really the important things are that we have no OH, no evidence of alkene. We still have alkane, sp3 hybridized CH stretch, and we have carbonyl. Okay. So to finish up, we are going to find peaks. And this time we can click maybe just a little bit lower and we get most of our important peaks labeled. That looks good. We are going to come back up here and replace. And now we are back in the main window, and that looks good. So now we are going to print this, and then we are going to remove our sample. We're going to use Kim wipes to wipe off the salt plate. And we're gonna just keep wiping it. We're gonna leave it for a little bit. We're gonna wipe it off some more. This product smells really strong, so it'll be quite obvious if we haven't cleaned it completely. Often just wiping it off with Kim wipes is okay. If we need to, we could rinse it with some dry dichloromethane. So we have to do that with our gloves on because that's not, dichloromethane isn't good for you. and we need to do that in a hood. So we will do that if it is necessary. But we're going to take this out. We're going to bring the salt plates back over here, clean them up, and then we're going to put them back in their little container and then back in a desiccator so that they will stay nice and dry. And we're going to take our product back to our lab space.